So question 12 says use the distributed property to find each product, and you're encouraged to use a generic area model to organize your work if needed, or just an area model. The first one, I probably don't need one, because I just have a factor of 4x that I need to push through. So each one of these terms inside the parentheses is going to pick up a factor of 4x. So this is equivalent to 4x squared and then minus 12x. If you'd like to see that as an area model, it would look like this. Right? One of my dimensions is 4x, and then I've got some x, and I've got a negative 3 here. So this is just an area model. I'm not using algebra tiles, but when I multiply the 4x times x, you can see the 4x squared, and when I multiply the 4x times negative 3, that's the negative 12x. So not needed in that case for me. Certainly needed for B. In B, I have a trinomial times a trinomial, and I'm going to definitely organize my work with a generic or with an area model. So I need to have 3 divisions going both directions, so it's a 3 by 3 grid. There's 9 elements in here. Some of these may be like terms. Across the top, I'm going to go, well, I guess down on the left, I'm going to write an A, so plus A, and there's a plus B and plus 2. And then across the top, we'll write the A, and then we'll write the negative 2B, and then the final one we'll write down as the 1. So let's fill in all the areas of each of these rectangles. The one in the upper left-hand corner is A times A, so we have here an A squared. Next I've got a negative 2B times A, so I'd write that as negative 2. I'll just write AB. And then finally 1 times A is A. Next row down I've got A times B, so I'll just write an AB there. And then I've got a negative 2B times B, so that looks like negative 2, and B is getting squared because I've got a B times a B. And then for the last box in that row, I've got B times 1, which is simply B. And then for our last row, I've got 2 times A, which is 2A. And then I've got a negative 4B. And then finally, 2 times 1 is 2. Now, as we look at these, it turns out a couple of these are like terms, so I can combine the negative 2AB with the AB, and I can also combine the B with the negative 4B. But everything else is distinct, so I can't combine the rest of them. So it turns out that this answer is a little bit longer than the line that you were provided with. So I'm just going to put an arrow here, and for the answer, I'm going to write. I'm going to put my squared terms first. So I'll write A squared and then minus 2B squared, and then I guess I'll just put my A's. Oh, oh, I can combine some A's. I didn't notice that. There is there's definitely a 1A and a 2A, so I can combine those. I'll go ahead and put those next. So then I'll just say plus 1A plus 2A would be 3A's. And then in terms of B's, I've got a negative 4B and a positive B, so that's going to be a negative 3B. The next thing I can combine is the AB. I've got an AB that's positive and then negative 2AB. That's going to make a negative AB when I combine those. And I think my final value is just the plus 2. So I'm kind of wanting to double check it here. I've got I guess I'll cross them out with a gray line if they're up there. So I've got the A squared's done. I've got the minus 2B squared is done. I've got the A and the 2A, which is 3A. I've got the negative 4B plus B, which is negative 3B. I've got the AB and the negative 2AB, which is negative 1AB, and then finally I've got the 2. Yeah, everything's accounted for. So this is the what this product is equivalent to, right? If I were to multiply If these were the dimensions of a rectangle, this is the area that I would get. A squared minus 2b squared plus 3a minus 3b minus ab, and then finally plus 2.